For today's science lesson, we are starting a new unit on chemical and physical changes. The vocabulary words for this unit are listed in the Google Classroom posting where you found this video. You need to know those words. You need to study them. Pay close attention to number 1, chemical change, number 3, physical change, and especially number 5, precipitate. That's a tough word to know if you don't memorize it, and I promise you will be asked a question on it. So make sure to pay close attention on your vocabulary words to 1, 3, and 5. I'll talk about the words as we're going through this lab experiment today. Feel free to look back at them if you need a refresher or if you're trying to figure out some answers for your questions later in today's lab. So, let's get started. Remember, we're looking at physical and chemical changes. For our lab, we're basically going to take a few different substances. We are going to subject them to some different types of change, and then we're going to observe what changed, and then we're going to use those observations to determine whether the substance went through a physical change or a chemical change. So, real quickly, the difference between a physical and a chemical change. A physical change only changes what something looks like, not what it is. So a physical change is going to change the size, the shape, or the state of matter. So what is this? It is a piece of paper, right? Nothing fancy. If I tear it in half, is it still paper? Yes. It's in smaller pieces. Yep. It's in different shape. Yes. But it is still paper, the same substance I started with. So that is a physical change. We only changed what it looks like. A chemical change is a little more intense. A chemical change is whenever a change causes a new substance to be formed. We'll look at a couple examples of that later. But the main information is that for a chemical change, a new substance is formed. And there's also a few indicators of a chemical change. So if we watch a change happen and any of these 5 indicators show up, we will know that we're observing a chemical change. So things like if a chemical reaction causes light, that's a chemical change. If a reaction causes heat, to be created, if it creates a smell, if it creates a gas, if it creates a precipitate, or if there's a change in color of the substance, we know we have a chemical change has occurred. Like I said, we'll look at a couple examples of that. It'll make more sense as we go through. So let's eyes down, look at our paper, and we'll get started. So this is the sheet, the lab page. You should have in front of you. So we're going to look at, in this chart for the first part, we're going to, we have a few different substances: apple, paper, a glow stick, milk, vinegar, and an ice cube. We're going to subject each of these to different types of reactions. We're going to observe the changes in the substance that those reactions make, and then we're going to use these observations to determine if we have a physical change or a chemical change has occurred. To start, we're going to keep it kind of easy. Well, we're going to skip way down to the bottom. We're going to look at ice cube melts. Okay? There it is. So, I have an ice cube. I'm going to put it in this cup. Oh, I'm sorry, there's already a little water in there from earlier. All right, so I have an ice cube. I'm going to put it in this cup. All right, and we will set this aside, let it melt, and we can come look at it again at the end of our lab experiment. So let's go to number 1. Apple was sliced. So I'm going to take I have an apple. Now, if we're going to observe changes, we first have to make observations before we do anything. You've heard me say it. Making observations is a huge part of science, and you have to be able to do it. So let's make some observations right now. What do you notice about this apple? What can you tell me about its shape? What can you tell me about its size? The coloring? Does it look like it is ripe? Does it look like it's fresh? Does it look like it's old? Is it round? Is it flat? So changes we can see. It's like a red and gold, or red and yellow. There's a little bit of wrinkles up here on the top, so it's not a very fresh apple. It's definitely round. It is smaller than about half the size of a fist. Yep. All right. So now let's cause a change. So we are going to, it says apple was sliced. So we're going to slice this apple. There we go. And now, what changes have we observed? Well, simply in this box, write what is different, what has changed. Our size changed, our shape changed. We can now see the inside of the apple, whereas before we could just see the outside. So anything you notice that has changed. All right, and lastly, was this a physical change or a chemical change? Now, the question, whenever you're trying to figure out if something is a physical or chemical change, you need to ask yourself a couple questions every time. Is this substance still what I started with? Right? Did we start with an apple? Do we still have an apple? Yes. Was a new substance formed? Did we make anything new? I mean, we cut a piece off, but this is still part of the apple that we started with. This is part of the apple that we started with. So did we make anything new? No, we did not. So we do not have a new substance. So it cannot be a physical change. We changed how it looks, right? We changed its shape, we changed its size, but it is still the same original substance that we started with. So that is a physical change. We started with an apple, we ended with an apple. Physical change. Remember. All right, let's head down to 2. Apple was smashed. So let me get I'm sorry, 1 second. Let me get a Ziploc bag here. All right, so I'm going to cut a slice off of this. I'm going to put it in this bag just so our bits don't go everywhere. Seal that up. And we're going to crush this thing. All right, now that's good and crushed up. So now back to our paper. So change that observed. Well, once again, we changed the size of it, right? It was a wedge. Now it's all squished down. We changed the shape. We changed the particle size. We can see some juice in here now, right? So think about this for a second. We see juice. Is that juice a new substance, or is it still part of the old substance? It is part of the old substance. So while we do see some juice that we didn't see before, that juice is not new. It was there. We just kind of smushed it out. So was this a physical or chemical change? Well, let's ask ourselves the questions. Did we start with an apple, or what did we start with? An apple. What did we end with? An apple. Did we make a new substance? No. So this is a physical change. All right, number 3, paper was burned. This is where it gets exciting. So, there we go. All right, remember, we have a paper. Now, what's important here, if you go back to the vocabulary words, I'm going to turn this up for a second. If you go back to your vocab words and you look at, sorry, 1 second. All right, if you go back to your vocabulary words, you'll notice on number 2, it says signs of a chemical change, and there are a few of them. Signs of a chemical change: when a reaction creates light, that's a chemical change. If it creates heat, that's a chemical change. If it creates a smell, that's a chemical change. If it creates a gas, that's a chemical change. If it changes the color of something, that's a chemical change. If it forms a new substance, that's a chemical change. So, when we burn something, we actually see a lot of those. Does burning something create light? Yes. Does it create heat? Yes. Does it create a smell? Can you smell when something burns? Yes. Does it create a gas like smoke? Yes. Does it change the color of something? When this is burned, will it turn black? Yes. Does it create a new substance like smoke or ash? Yes. Each one of those by itself is enough to say that a reaction is a chemical change. But all together, if they're all showing up, we know pretty darn well that this is going to be a chemical change. So I wanted to kind of express that, let you know what to look for so that we can watch it. All right, so we have light being made. Oh, right here. We have heat being made. We can see a color change. You can't see it, but there is smoke coming off the top. There is ashes coming off the bottom. We'll stuff that out. Right, so I can smell it too. I can smell all that heat coming around. So, was that a chemical change? Well, did we make light? Yes, so that's a chemical change. If you're not sure, go to the next part. Did we make a smell? Yes, you can't smell it, but I can. So that's a chemical change. Did we make a new substance like ash? Yep, we sure did. Look, you can see the ashes in the bottom of it, right? This was not this before. This was paper. Now it is a new substance of ash. Another substance came off the top, the smoke. That was a substance. Chemical changes will always make a gas, which is, again, the smoke. So all those signs for a chemical change, it's important to know they don't all have to show up. We only need one to prove it's a chemical change. But with fire, we have like 5 or 6 or 7. So, something to remember. A couple things to remember from this is you only need one sign of a chemical change to be evidence for a chemical change. But burning something will always, always, always be a chemical change. If something's burning, it is going through a chemical change and a chemical reaction. Know it, right? Fire is chemical change. All right, let's head back down to the books. Back to here. So we're on number 3. Paper was burned. What changes did you observe? Well, we talked about it. We saw light. We saw heat. I told you there was a smell. We saw 2 new substances formed. What were those 2 new substances? It created a gas. What was that gas? So lots of reasons here, and I'll let you answer. Was that burning paper a chemical or physical change? Go down here. Number 4, glow stick. This is everyone's favorite. You guys have seen this before. It's a glow stick, right? So if we're going to have to observe changes on a glow stick that we snapped, first we gotta make observations now. So it is kind of a pale pink. It's in a tube, and it's long and thin, like a straw, right? Quick observations. Now let's snap it. to put it through a change. And what changes are you observing? What changes are you observing? Should be pretty obvious, right? We are observing this glow stick is now illuminated, right? It is now glowing, or we can say it is emitting light. It's giving off light. If I kind of make it in a shadow, you can see it down there glowing too. So remember, on signs of a chemical change, is light a sign of a chemical change? Absolutely. So number 4, glow stick snapped. What changes did you observe after it broke? Should be pretty obvious. And what type of reaction or what type of change has taken place? Should be pretty obvious. Oh, right there, sorry. So what changed when we snapped the glow stick, and does that mean it's a physical or chemical change? Come down here to a brown apple. You guys have seen this before. We'll look at it though. So looking at this apple, you can see that it is not quite as bright as it was before. It's kind of gotten a little brown. I'll pull this one out too. You can see this one really good. You can see it's gotten kind of brown, especially this one kind of along the edges here. Now, that browning is a color change, right? So on our paper, apple flesh browned. Remember, what color was this earlier? It was kind of like a pale or a white. Now it's getting kind of browned on the edges, right? So we are observing a change in color. And if you look back at your vocabulary words, you should be able to find the answer to this, right? So if the apple flesh changed color and turned brown, does that mean a physical or chemical change if it changed color? Now, one thing I want to talk about real quick for talking about color change. Now, there's 2 types of color change, right? One would be a natural color change. The other one would be like an artificial or a man-made color change, right? This paper is white, okay? If I take my pencil and I color this whole thing like this, am I changing the color of this paper from white to gray? Absolutely. But this does not mean it is going through a chemical change because I am making this happen. This paper is not changing color naturally or because of some type of reaction. This paper is changing color because I'm taking another color and I am coloring it. Right? So this would just be a physical change. But if we're looking at something like apple turning brown, or if we're talking about paper burning and turning black, okay, then we're talking about a natural color change. This changed because the paper burned it. Parts of the molecules were burned off. Some other crazy science stuff happened, and it turned black naturally because of the fire. We didn't color it black. It turned black. Our apple is turning brown because of something called the apple is turning brown because it is becoming oxidized. Oxidized is a term for when something changes because it is being exposed to oxygen. So this color change is a natural occurrence. It is occurring because it is becoming oxidized, and that is a natural thing. So this color is changing through natural processes. So is that a physical or chemical change? Another thing we can talk about while we're talking about substances oxidizing is you're probably very familiar with rust, right? We all know what rust is. It's like that brownish brittle that grows on, that can like form on metal. So when certain types of metal get wet and are then exposed to oxygen, they will rust. So we are, rust is first causing a color change naturally, right? Because it turns the metal like a reddish brown color, and rust forms on top of the metal. So the rust is not only changing color, causing a color change, but it's also a new substance that is forming. So remember, something rusting is going to also be a chemical change because it's changing color and it is creating a new substance. All right, let's move down here. Number 6, milk and vinegar combined. This is pretty interesting. Basically, if you take milk, right, so this is just standard lunchroom milk that I took off a kid's breakfast. All right, we take some milk, pretty normal, right? It is white, it is liquidy, not much to it. Now, if we add, you can't see, it looks like water. This is not water. This is vinegar. You probably have a jug of it at your house that your mom or dad might use for cleaning. If you eat pickles are cucumbers soaked in vinegar. Vinegar is a very common and safe product in our households. But if we add vinegar to milk, we will see something interesting happen. Now, look at what's going on down here. If you look closely on this side, you see these little bitty like specks forming. It's going to continue as it goes. You can kind of see it turning a little yellow right here in the middle. So what we're watching right now is we are watching this milk essentially go bad right in front of our eyes. So when we added the vinegar to the milk, the vinegar basically spoils the milk, and the milk starts turning to curds, which is like the beginning of cheese, kind of. So this now spoiled milk is forming chunks in it. I know that's gross, but you can see if we do that to the side. So look right here. You see all of these. There we go. You see all these specks floating up on the side, right? See the little specks right here? Those are not drops of milk. You can even see some forming in here. These are not drops of milk. These are solid particles that are forming because the milk is going bad. So we are seeing solids form in a liquid. And if you look at your vocabulary words, look at number 5, and that's what you're seeing right now. This is number 5 in your vocabulary words that we are seeing. These individual little chunks that are showing up, these are called precipitates. And it is a precipitate is evidence of a chemical change. A precipitate is whenever a solid forms in a liquid. So when we added the vinegar to the milk went bad, and these little chunks started to form. Now we can leave this sitting and it will keep forming, and these curds will keep forming. I'm going to show you this one that I did way earlier, and look at all that. Disgusting. So these are precipitates, right? Solids that formed in a liquid during a chemical reaction. So come back here. Changes observed, milk and vinegar. What did you observe? What is now in here? What do you now observe is in this milk that wasn't there before? And remember, there is a word for it in your vocabulary. And does that show evidence of a chemical or physical change? I'll let you figure that one out. And lastly, down to our ice cubes. Get that nasty milk out of there. Down to our ice cube. Well, our small ice cube is now an even smaller ice cube. You can see it. It's that little speck right there. That's our ice cube. think it might have... All right, so our ice is now completely evaporated. All right, so now our ice has... Okay. Now let's look at ice cube melted and changes we observed. All right, well, it is no longer an ice cube. What changes have we observed? Well, it's melted. It's no longer solid. It's now a liquid. So, did it go through a physical or a chemical change? This one's tricky because what substance is in this cup right now? What is this liquid in the bottom of this cup? It's water, right? Well, what substance is ice made out of? Ice is also made out of water. So we started with frozen water. Now we have liquid water. Do we have a new substance, or are they both just water? They are both just water. Ice is water. Liquid water is water. So we do not have a new substance. We had water to start. We have water to end. So is that a physical or chemical change? If you're not sure, check your notes or check your vocabulary notes. The information's in there. All right, and I'll leave the rest of this up to you. There are 4 questions, just talking about what we saw up here. Why is cutting the apple considered a physical change? Why is burning the paper considered a chemical change? Lots of reasons. What was produced when the milk and vinegar? That's weird, that's a typo. All right, what was produced when the milk and vinegar mixed? I want the vocabulary word in here. All right, I want you to explain, I want you to tell me what was the word of what was produced and explain it. And last question, is the glow stick the same as it was before it was snapped? Well, it is definitely the same shape, right? It's definitely the same shape. But is it the exact same? No way. It's not the exact same. There's something different coming off of this glow stick that wasn't there before. All right, that is it for today's science. Hope you enjoyed it. All right, we'll see you guys next time.